All right, guys, so we're starting 1.3 today. And we're going to work about half the time on the note sheet, and then the second half I will give you time to work on the assignments. So any questions on any of the homework so far? On sections 1 or sections 2? Now, section 3 is talking about right triangles. Now, you've dealt with some of these so far, sine, cosine, tangent. And these are all going to be with a right triangle. So the opposite side and adjacent side are going to be all dependent on which angle we're talking about. Because if we call this theta, then this side would be the opposite and this side would be the adjacent. Now, if we call this one here alpha, then this side would be the opposite and this side would be the adjacent. Because the adjacent and opposite sides are all dependent on which angle we're talking about. However, the hypotenuse will always be opposite the right angle. So it's kind of set in what it is. And what we're going to be looking at with some of these here is finding all 6 trigonometric values. So sine of theta, cosine theta, tangent of theta, secant of theta, cosecant of theta, and cotangent of theta. But really, if I can find sine, cosine, tangent, we will have secant, cosecant, and cotangent, because they're just going to be 1 over sine, cosine, tangent, or the flip of them. Now, before we can find any of these here, we need to finish the triangle, because they gave us 2 sides of a right triangle, so we need to find the third. So we can use a squared plus b squared equals c squared. Since it is a right triangle, we can use the Pythagorean theorem, where a and b are the 2 legs, and c is the hypotenuse. Well, they give us both of the legs. So we have 3 squared plus 4 squared is equal to c squared. Questions on this so far? Now, before we calculate anything, does anybody have a guess at what the hypotenuse is going to be? If not, that's fine. Now, if we calculate the left side, 3 squared plus 4 squared, those are both numbers. We're not solving for either one of those. So what we could do is I can grab a calculator and say 3 squared plus 4 squared and get 25. So c squared is equal to 25. At this point here, we can square root both sides. Square root of c squared is just c. Square root of 25 is 5. We would normally put plus or minus whenever we take the square root of both sides. But because we're talking about a length, we know the length cannot be negative. Now this one here is good to know. 3, 4, 5 is one of the Pythagorean triples. And ACT loves using Pythagorean triples. 3, 4, 5 is one it uses a lot. Now, you might normally see it as 3, 4, 5. You could see it as 9, 12, 15. Because what did they do? They multiplied each one by 3. This is the same one. Or we could say 30, 40, and then, yeah. They like using these, or different multiples of them. to find the missing side. Or they could give you the hypotenuse, which is a multiple of 5. Give you one of the sides, say 4, which is the same multiple of 4. Then you find the other one. Well, if you see that it's a 3, 4, 5, we can find the other without actually calculating anything. Now that we have that, we can find our trigonometric values. Now, sine is opposite over the hypotenuse. Well, the opposite side to our angle is what? Opposite over hypotenuse. So the opposite side would be 4, and the hypotenuse is 5. Now, cosine is going to be adjacent over the hypotenuse. The adjacent side is 3, and the hypotenuse is still 5. Now, tangent is opposite over adjacent. The opposite side is 4, and the adjacent side is 3. Now, the next one I listed was secant. We don't necessarily have to do secant first, but secant is going to be hypotenuse over adjacent. Well, the hypotenuse, I don't know why I wrote it YP. Or PY, so hypotenuse. Well, the hypotenuse is still 5, and the adjacent side is still 3. And as we can see, secant is just 1 over cosine. Now, cosecant is going to be hypotenuse over opposite. And as we've seen already, the hypotenuse is 5, the opposite side is 4. And lastly, cotangent is adjacent over opposite, which is going to be 3 over 4. And hopefully you notice with these three here, secant, cosecant, and cotangent, we just took our sine, cosine, and tangent and just flipped whatever the value was, respectively. Now, if there is a radical in the numerator, when we flip it, it'll be in the denominator. We do need to simplify those, but luckily for us, the TI-30XS, our little yellow calculators, will simplify radicals very easily, and we don't have to do a lot with them. Questions on this here? Now, hopefully you notice with this here, we can't actually just use a calculator and plug in sine, cosine, tangent of the value to get our answer because they didn't give us that angle. So we can't necessarily use the angle to get the values. And all of our answers for these here are going to end up as fractions. Now we're going to do the same thing here, but this time instead of giving us two of the legs, it gave us one leg and one of the, well, not one of the hypotenuse. So we need to find the other leg. So again, we can still use a squared plus b squared is equal to c squared. I can plug in a as 2, and we'll plug c in as 4. Well, 2 squared is 4. 4 squared is 16. At this point here, we can subtract 4 from both sides. telling us b squared is equal to 12. Again, the next thing we're going to do is take the square root of both sides. And luckily for us, the square root of b squared is just b. Now we need to take the square root of 12. Well, square root of 12 is plus or minus 2 square roots of 3. And again, we can do that in the yellow calculator. 2 square roots of 3. But really what we're doing is trying to find perfect square factors of 12. And there is one. It's 4. 4 times 3 gives us 12. Square root of 4 is 2. Can't take the square root of 3, so it stays inside the radical. Now we don't include the plus or minus because normally we would. We would say plus or minus 2 square roots of 3. But because we're talking about a length, a distance, it can't be negative. Questions on any of this here? Now, will the value for sine in these triangles ever be greater than 1? No. Because what is the longest side of any triangle? The hypotenuse. The hypotenuse is guaranteed to be the longest side no matter how we set the triangle up, yes? And sine is the opposite side length over the hypotenuse. Well, as we just said, the hypotenuse is always the biggest side. So is there any way the opposite side length could ever be bigger than the hypotenuse? There's no way it could be greater than 1. And actually in a triangle, in a right triangle, there's no way for the opposite side to be greater than the hypotenuse or equal to it really, unless we get out of Euclidean geometry. We talk about spherical geometry or other types of geometry, because on a flat plane, a triangle can only have one right angle, so this is kind of stuck at these values. Now, looking at this here from our given angle theta, the opposite side is 2, our hypotenuse is 4. Well, we can't really leave it as 2/4. It's actually 1/2. Well, that also tells us what cosecant is. Cosecant should be 2/1 or just 2, because it's the hypotenuse over the opposite side, which is 2/1 or just 2. Really, it would be 4/2, which is just reduces to 2. Or we could flip it and just say 2. Cosine is the adjacent side over the hypotenuse. Well, the adjacent side, as we saw, is 2 square roots of 3 over 4. And again, this will reduce to square root of 3 over 2. Tangent is opposite over the adjacent. Well, the opposite side is 2. The adjacent side is 2 square roots of 3. Now, the 2/2 will reduce, yes? But what's left in the denominator? You're right, our square root of 3. Well, we can go on and just type it into the calculator. 2/2 square roots of 3. 3, so square root of 3/3. Now, I could have typed it in as 1 over the square root of 3 also and got the same thing, because the 2/2 would reduce. The numerator reduces to 1, because anytime we're dividing like terms or have a common term on top and bottom, it doesn't reduce to 0, it reduces to 1. And when we simplify it, we get the square root of 3 over 3. Now, for just a little case in point, I will reduce that for us so that we can see this. And there's a reason for it here in a minute. So any questions on how we found sine, cosine, tangent? Really, we jumped to cosecant. We could have done that as well with secant before we got there, because secant is the hypotenuse over the adjacent side, which if we did it step by step, the hypotenuse is 4. The adjacent side is 2 square roots of 3, which is really just going to reduce to 2 over the square root of 3. Now again, we could plug this into the calculator, which is going to give us 2 square roots of 3 over 3. And we have this here. There's nothing else that reduces. Questions on this here? Now cotangent is adjacent over the opposite side. Well, the adjacent side is 2 square roots of 3. The opposite side is not 4. That's the hypotenuse. The opposite side is 2. Well, that will reduce to the square root of. Now, it might have seemed odd a minute ago that I reduce it to 1 over the square root of 3. But what happens when I flip 1 over the square root of 3? It becomes. So that one there, reducing it and then simplifying the radical, actually would have helped us because it immediately gave us cotangent. You all see how that kind of works? Now, even if you didn't do that step and we plugged it all in at the beginning, I could have easily just taken 2 square roots of 3 over 2 and simplified it there. So there's not a right or wrong way. There's just some that save us a few minutes, and that's about it. Questions on sine, cosine, tangent, secant, cosecant, and cotangent. Incidentally, without any calculations, we can actually tell what the measure of angle theta is. Because I don't know if y'all brought your unit circles out, but if we looked at the unit circle, well, this, calligraphy pen back out, cosine always goes first. It's x square root of 3 over 2 comma 1/2. Point on the unit circle is our 60 degrees. Pi over 3. Angle. Questions on any of this here? Now, what I'm going to say for this next part here is going to hold true for most things, and especially with the ACT, because I'm suspecting both of y'all are probably going to take it soon. If it talks about a shape, if it talks about a figure, if it gives you some type of information like this here that's representing or referencing a shape, figure, chart, and they don't give it to you, especially on these here or on the ACT, draw it. Actually draw it. Because here we're talking about right triangles. So first thing I would do is draw a right triangle. Because we can go purely by definitions and try to go that way, and that works. But if I can have a picture, I would prefer having a picture. And what they're telling us with this here is that sine of theta, that is just an angle, is equal to 3 over 5. Well, we know sine is what over what? Opposite over the almost hypotenuse. So the opposite side is going to be 3. The hypotenuse is 5. By just drawing this and putting in the information we now have a better grasp of what we need. Well, now we need to find the adjacent side to the angle. And what's it going to be? Because we have a side length of 3, missing the other, and the hypotenuse is 5. So the other side has to be, because this is a 3, 4, 5 right triangle. Now, it's not too hard to show, because a squared plus b squared is equal to c squared, because if you forget about the 3, 4, 5, that's perfectly fine. Because we can say a is 3, leave b squared, and c is 5. Well, 3 squared is 9. 5 squared is 25. minus 9 from both sides, telling us b squared is equal to square root. B is equal to plus or minus 4. We know it's a length, so it's just 4. Both of those ways will get there. Now we'll get to some of the, let's see here, cosine, theta, tangent of theta. Now, out of all these here, there's one of them that we really didn't need to calculate anything for, and that's cosecant. Because cosecant's 1 over sine. It's just the flip of sine. Well, since I have sine as 3/5, cosecant is 5/3. We just have to flip it. Now we can go about finding the rest from here, because cosine is adjacent over the hypotenuse, so 4/5. Tangent is opposite over adjacent, so 3/4. Secant is hypotenuse over adjacent, or the flip of cosine, so this would be 5/4. Cotangent is adjacent over opposite, or the flip of tangent, which would give us 4/3. And that's it there. Questions on this here? Yeah. We'll stop here for today.